Hey, hey, everybody. Happy Thursday. Hope you're doing well. There we go. All right. Got a couple things on tap today. Let's take a look here. First off, my apologies. I'm still so far behind on these projects. I'm working on getting caught up, but it is slow going. I'm sorry. Also, I am hopped up on cold medicine. My little guy and I apparently maybe spring allergies or whatever it is. He didn't sleep last night unless he was propped up like against my back. So it was a rough day, rough night. I actually missed the morning class, took a bunch of cold meds if I could make it through the afternoon classes, and now I still have my mug of coffee so we can make it through tonight. So we should have a lot of fun tonight. Oh yeah, that's awesome. Oh, I don't sound good either. Yeah, it's just all up in here. It's terrible, but we'll get there. And I hate canceling on the once a week classes because like we miss a whole lot of content at that point. So I'm gonna try and power through. Oh, thanks so much, Mark. I appreciate it. Yeah, I think we'll get there. Just the little guy's not big enough for cold meds yet, so like it's miserable. He likes to get in the shower where it's all nice and steamy. That kind of helps clear up your sinuses a little bit or something. I mean, honestly, Sticks, we had 4 weeks on this one, so I don't know if another week's actually going to do anything, because, let's be honest. And I do recall, thanks, 27 TTV. Yeah, I think he'll feel better soon, but it's rough. Yeah, so I slept through the morning class, but we meet twice a week, so canceling's not quite as big of a deal. I don't know. I don't feel quite as bad. But we'll talk about the project today. I sent the link out. Hopefully you saw the Tuesday morning session. Went through a couple ideas on Project 3. Not Project 3. I want NetBeans. That's what I want. So I put that out for you folks to see. Hopefully you saw the link in Discord. If you're not on the Discord server, you definitely should join. And then it even gives you a chance to get to know your classmates, because the final project you are welcome to do in pairs. It's a little bit of extra work to coordinate, make sure you're not messing up each other's changes. I can get you guys set up with a shared repository that you both have access to. And there's a couple tips and tricks, but mainly you just always want to poll before you start and commit early and often. And we can go from there. But yeah, get to know your classmates in Discord, or I can even open up like a discussion in D2L if you want, specifically there. And then there will be no fourth individual project. Oh yeah, the built-in live share, that's really cool. I've used that before for a couple .NET things, but I don't use it for Java. But no, that's cool. All right, so we talked a little bit about Project 3 and got through like designing a couple classes and looking at how these things might interact just a little bit. Just a couple ideas there, because I had gotten lots and lots of questions this last week on the project, given it was coming up due. And I heard the study sessions went relatively well. Yeah, I heard the study sessions were good, so definitely take advantage of those. Tuesday 4 to 5, Wednesday 6 to 7, Thursday 4 to 5. So one of those at least will work for your schedule. I know it's hard to schedule anything with life, but we'll do our best. Okay, so we looked at a couple of these here. Awesome. So far, the game loop, right? What actually runs in main, we are putting off for now. That was the extra credit bit if you wanted to. What we needed to do was design all of our classes so that we could interact with them in the game. So the idea, it's a turn-based racing game, which seems really weird, but that's okay. We're not to the point where we can actually do this live or anything. So, all right, 16 out of 25 submissions. That's one less than last project, so maybe that's okay. I'm feeling a little bit bad there. And then I did mention, don't remember if it was last week or not, when you do your final project, I can take the score of your final project, your percentage score, and I'll use that to replace your worst individual project. Because sort of the goal is everyone gets 100% on the final project, right? I mean, I said before we're going to have a month to do it. and you had a month for this one, and based on some of the comments, I don't think everyone's getting 100%, but for the final project, maybe we'll have picked up that lesson a little better. It's 25% of your overall score for the class, and whatever percentage you get on that, if it's better than one of your individual projects, I'll go ahead and replace it for you. Because really, if you can do well on the final project, then, I mean, we're using all of these tools and techniques and things that we've learned in the individual ones. So, yeah, keep that in mind. All right, so we're just building the classes here. So you have an abstract base class for cart. Right, so cart is this abstract class here. We had a midterm, Crow. I usually get funny looks when I turn in syllabi that don't have exams. I'm working towards that as my goal, because I think exams are terrible. I'm a fan of quizzes, but they're just open book, open notes, you know, untime-bound quizzes, I think is probably the way to go. And you know, to be honest, as a professional software engineer, no one has ever asked me to do something from memory, because that's stupid, right? Like, why would you not use your resources, use your tools, look stuff up to get the right solution? Why is it that we care if you can get the right solution from memory? So I'm, you know, typically against that sort of thing, and I understand we need to have some way of measuring what you've learned in a course, but I don't think exams are good for that. That's just me. Like, the time pressure gets to a lot of people because, you know, I don't understand why getting the right answer slowly is wrong compared to getting the right answer fastly or quickly. Told you I'm on cult meds. I don't have any words, less words than usual. All right, so we started looking at cart. Right, we said, hey, well, if cart has a constructor that takes some attributes here, when we create subclasses of cart, like motorcycle, we need to call that constructor, and we can add those attributes. Right, so whatever motorcycle speed, acceleration, brake speed it is, we're going to add 3 to each of them, because that's what our rule was here for carts. Motorcycles, they have the best acceleration, brake speed, and max speed, and our constructor will give those as like bonuses to it. But what happens, the downside for motorcycles, they're faster, but they wipe out, and they lose an extra turn. So it's just sort of this idea that we've got a base class cart that we're extending here, okay? So other things that cart needs to know about itself, right? It needs to have some attributes, and it probably makes sense to make most of these protected. I'm not sure private makes a lot of sense, because we know we're going to have base or subclasses. We know people will extend this. We're going to be extending them. So I'm going to default all these to be protected. Protected. Int max speed, a protected int for acceleration. Yeah, I'm just going to copy paste. I don't have to type again. And a protected int for brake speed. And then in our constructor, we just set them, right? Whatever you give me, we'll take. Max speed, this acceleration. And this brake speed is the brake speed. Okay, we'll set all those. Great. Other things that cart needs to know about itself, right? An item, right? So we can use items. We need methods for accelerate and brake. Get methods for all of our things. A method for use item, right? So our carts can use items. So we'll have a protected item. Remember, like, item is just an interface here. Item just says, hey, you can use me as an item. And we're going to write classes that implement this interface. So the banana will implement it differently than the shell, which will implement it differently than the mushroom. And we're just coming up with a couple items that we can use here. It is, they have an interface. We can treat them as their interface type with this cool polymorphism thing. So I don't care what kind of item it is. As long as they implement the item interface, I can treat them as the interface type. Right, which is cool. So we need a way then to be able to get items, right? So we'll have a public item, get item, returns the item, sure. So we can see what item we have, right? And then we need a way to add an item. So I'm just going to make a void method here. Maybe we could make a Boolean. I don't know if it matters or not, whether or not we successfully picked one up. We'll call add item. Given an item, we'll call item. And if you remember the rules to kart racing, our terrible version of Mario Kart. If you already have an item, you don't get a new one. Right? So if you did that, great. If you didn't, that's okay. I mean, I'm not too particular around how you were doing that, but you can only have one item at a time. So I'm going to say if item is null. Oops, that's lowercase I item. If my this item is null, then I'm going to take it. I'll say this item is the item. That's it. So if I don't have an item, it'll set it. If you just took it every time, that's okay too. We changed it up. There was no hard or fast rule for that. So I've got a way that I can add items now. We need a way to get these particular values out here. So let me add some get methods here. You know what? And also, we talked a little bit about how we can track position. So one of the ways, right, because the cart is supposed to know, the track is supposed to know where the carts are, you could have like a parallel array list of positions. I'm not really fond of that. I think it's probably better to add a position attribute to cart. And so the cart would know what position it's at in the array list. Same kind of thing, this item to pick up. If we have items along the track, maybe they should know where they belong. Again, just trying to find out what's the best place to track this. And it's really an art. And that's what I love about programming is, while there's a lot of science to it, this design piece is an art. Right? And the more you do it, the better you're going to get at it. You'll understand, well, okay, these are how these classes should interact, and these are the attributes, these are the methods they should have. It's all an art of designing it. So I'm going to add that as an integer. Let's have a protected int position on track. Okay, so then remember, our constructor's job is to give all of our attributes values. So our position on track will start at 0, and our item will equal null. Now we know reference types by default get null, and that's okay. But I want to be very explicit in our constructor and do that. Yeah, so we just use an int value. So we're just like, everything's in units, like you're 7 units along the track, or you're 29 units along the track, you're 1,000 units along the track. Whatever we want to use is okay, and whatever we want to call those units. Right, and the idea is that you would go your current speed. So we also need a current speed. Protected int current speed. You would go your current speed along the track. So current speed is 0. Yeah, just add to its current position for sure. That's a good way to do it. Oh, a dad joke, you got it. That guy. Oh, my little guy's got my phone right now and he's watching YouTube to keep him entertained because he's a grump. Excuse me. Let's see, I just had clipped a really good one. What was it? Hang on, I can find it here. Give me just a minute. Don't worry. Don't worry. I've got him here. This is going to be worth it. This was a good one here. And I gotta go find all those. Where did I put them? There we go. Camera roll. Yeah, okay. Where was it here? This one. So a priest, a pastor, and a rabbit entered a clinic to donate some blood. And the nurse looked at the rabbit and said, "What's your blood type?" And the rabbit said, "I'm probably a typo." I like that one. That one, it's a good play on the usual joke. All right. Right, so our constructor should set our attributes. Yeah, I've always found going over projects to be a good approach. The downside is it means I can't take things late, but I mean, by the time you're in college classes, we should be used to getting things in on time. I've never been a fan of saying, oh, we'll just take 10% off if you turn it in late, or that sort of sliding scale. And honestly, that's more work for me to try and understand like how many points you get taken off because you got it in late. So I'm all about making less work. So. Excuse me. Whew. I'm gonna need some more coffee. All right, so we set a bunch of attributes, right? And then we need all of our gets here. So let's go insert some code here, and let's add a bunch of getters. Sure, all these things. Probably fine. Okay, get max speed, get acceleration, get break speed, get position on track, get current speed. And then we have this idea of entering a bend. Remember, so the idea is if you enter a bend, And where did we talk about those? So a bend has a max speed assigned. If the cart goes into the bend, or you cross the distance at which it starts above the max speed, it goes off the road and stops. Yep. So if we enter the bend, we need to see what that max speed is. So the bend class had a max speed in this position on the track. And this way the track can track and track can track all of these bends without having like this parallel array thing like that. So sure. Excuse me. This was a little bit harder. So the item interface can only define methods. We can't say it has an attribute, but we could add a method like get position if we wanted to. And then each item would have to be able to set its position on the track and get the position on the track. We've got some options there, but we'll try this one at a time here. So when we enter a bend, where we need to see if our current speed, so if our current speed is greater than the bend dot, oops, we don't have any methods in bend. Right, so let's add a constructor. We'll add some get methods first, and we can add the constructor, why not? Look, we can generate a constructor that takes some attributes. Look at that. Code, our program is writing code for us. That's amazing. Then we can add some getters. Done. Okay, look, we take a max speed, we take a position, we set them as our private attributes. We get a max speed, we get position on track. I like it. So in the cart then, we can say bend dot get max speed. So if our current speed is greater than the max speed, we've wiped out. Our current speed gets set to 0. Woof woof. Right? That's the default for cart. And remember, this is going to be different here for light carts. light carts, then when they enter a bend, they get a chance to brake before taking that penalty. But the heavy carts and the motorcycles don't get that opportunity. Okay? So that's our default. Okay? Not a problem. Okay, so that's what happens when we enter a bend. So it just sets our speed back to 0. We need a way to accelerate. Void accelerate, given an int, I don't know, units to accelerate or something. Acceleration, maybe? I don't know. Why not? And what we're going to do is we have a max acceleration, or I'm sorry, this should be like max acceleration. I probably named that badly. So a refactor rename, right? Don't do this by hand. Use your tool. This is our max acceleration. Oh, we should have renamed getters and setters. I messed that up. Hang on, let me undo. Undo rename. My mistake. Refactor rename. Take advantage of the tool. Right, we have to rename getters and setters. There we go. Max acceleration. There we go. I like it. And same with brake speed. That's probably max brake speed. Right, that's the most that we can brake. Okay. All right, so when we accelerate then, we're going to check to make sure, right, if the acceleration is greater than the max acceleration, then we're going to change acceleration to max. Right? So you tried to accelerate by 100 units and the most you can accelerate is by 5. Sure, well, we're only going to go up by 5. So what we do is we're going to take our current speed and we're going to add to it the acceleration. And then we need to check if current speed is greater than the max speed. Right? If we accelerated more than we should have, oh, curly braces there, then we're going to take our current speed and set it to max. Nope, max speed. Okay? That's how we can accelerate. So you tell me how much you want to accelerate by, how many units. We're going to make sure it's valid, and then we're going to accelerate, and then we're going to make sure we didn't go over max. Okay? Same idea with braking. So public void brake. Int brake. Oh, yeah, we can't call it brake, can we? Braking. That's right. Or slow down. Brake is a reserved word. Remember, like from loops and things. So I don't know, we'll call it braking. Int braking speed or something. I don't know. Braking amount. Sure. Okay, we'll do the same thing. If the braking amount is greater than our max brake speed, then we're going to brake by our max brake speed. Okay, and then we can decrease our current speed minus the braking amount. And then we should check if current speed is less than 0, probably put ourselves at 0. and give that a little format. Take out some of those new lines. So same idea. So we can accelerate by up to our max, and we can brake by up to our max. Now, most of the time in a racing game, we're going to accelerate by max anyway. So if you didn't have this as an argument, that's fine. But braking, you might not want to brake by your max. You maybe wanted to just brake by 1 or 2 if you saw a bend was coming up and we were close to that max speed. Just a thought there. Okay, all right, that's looking good so far. Where do we close that? Okay. Awesome. That's really good. 27. I have to do the Roman numeral math every time. Can I just call you TTV? Okay, so we've got ways we can brake and accelerate now. What else did our cart need to do? Right, cart needed to be able to use an item. Right. So we went into the bend, we went off-road. We need to figure out a way to get the distance of the next bend. So we could tell the cars, how far away they are. Here's our item interface. A cart can only have a single item. Randomly assign one of those. So the cart needs to be able to use the item that it has. Right? I think we didn't have a use item, did we? Oh, it's okay. I think the handles thing is actually kind of fun, and then you get to be anonymous if you want, or not anonymous if you don't want. So totally up to you, Mitch. All right, so we need a way to use our item. So I don't know, void use item. Now, to use the item, remember our item then had a use method, but it needed a cart and a track. And right now we don't have a track. Right? So maybe one of the things cart needs to know about itself is what track it's on. Kind of this relationship, like the track knows that it has the cart, but the cart also knows what track it's on. Because we need to be able to have this work both ways. Or we could say use item requires a track, and we could pass the track when we call use item. Again, it depends on how you wanted to design it here. So I think it probably makes more sense for us to say, hey, give me a track. Right? We'll have a track here in the constructor. Protected track, and then we'll set the track here. Dot track equals the track. Because that way I can pass it my track here. Right? We'll have it, and we can use the item. Item used. Done. Right? The item can figure out what to do from there. Right, because either it's going to shoot something, it's going to make us accelerate if it's a mushroom, or it's going to drop the banana. Okay? Excuse me. Now, of course, motorcycle's upset because it needs a track first. So track. Then we pass the track to the superclass constructor. Okay? So we got that. Okay, so we can use the item, but then when we're done using the item, right, my item should be null. Right, we've used it. Null it out, so that way I can pick up my next item. Okay? All right. How are we feeling on cart so far? Let's see, does it have all the things we needed? And I did put a rubric out there finally. Sorry for the delay on that. So the abstract class has all of its attributes, and then heavy cart, light cart, motorcycle, track class, item interface, items implement the interface. That was all we needed, right? With just the classes here. But we need ways for them to interact. So you have to figure out how all that works. Okay? So then our banana item, right? When we go use banana, given a cart and a track, it's going to, we talked about, hey, maybe the track needs a way to know that we're dropping an obstacle. So we drop an obstacle at a location, and we could either give it the cart, or at this point, the cart's position. Either one is up to us. Doesn't matter too much. So let's take a look at track. So drop obstacle at location. If we were using this parallel list, we would need the cart instead of the position. If we've added position to cart, then we can just add it to the track here. So I might have a private array list of type, I don't know, call it item, or I mean, really this is just integers at this point, called like obstacle on track. Right, so we could just add it to our obstacle that's on the track. Dot add, and what the integer we're going to add is the cart dot current position. Get current position. Don't we have position? Oh, position on track. That's what it's called. Position on track. Position on track. Get position on track. There we go. So we'll add it there. right? And then what's going to happen inside of that game loop when a cart moves over a given position, right? Same with the bends. We need to see, hey, if you've crossed that line in your movement, we're going to say, hey, you got hit by a shell. Or you got hit by the banana, right? Because we dropped it there. Okay? And then what happens, right, in cart, when you get hit by an item, you need to spin out. Right? So we need a way to tell the cart that it spun out. So man, I'll spin out here. And really, that's where this happens here. Right? Our current speed goes to 0. So we're just going to call spin out here. Spin out. Right? So anywhere our speed goes to 0, we can just call spin out. Okay? So sure, if we get hit by a banana, we spin out. And the track or whatever's in the game loop is going to manage that by figuring out, hey, if the cart was at position 5 and it went to position 10 because it moved 5 units, if there was a banana at position 7, we've crossed over, we hit it. That sort of thing. It's not the smartest logic in the world. But all that would happen inside the game loop, right, where we have to manage all of that. Okay, so motorcycle. What makes motorcycle special? Well, it does all the things cart does with these additional modifiers, but then when it spins out, something else happens. Right, remember, motorcycles need to lose an extra turn when they spin out. So what we need is a way to be able to track whether or not we have spun out and we need to lose a turn. But because we deal with everything as carts, right, everything deals with the abstract class type, it needs to be an attribute here. Because that way I can ask the cart that's in my list of carts, hey, did you lose a turn inside of that game loop? So it'll have like a protected Boolean for lost turn. Right, and anytime we have attributes, we need to set them in the constructor. So my lost turn equals false to start. Okay. And then what we can do in motorcycle then, we want to override the spinout method. Override, sorry, public void spinout. Okay, what we want to do then is we want to say that my lost turn is true. We lost a turn when we spin out. So when we enter a bend and spin out, we lose a turn. We get hit by a banana, we spin out and lose a turn. When we get hit by a shell, we spin out and lose a turn. So what we're going to say is, hey, when we spin out, we're going to lose a turn. Okay. Then we also need a way to change that, though, right? So after we've lost our turn, we need a way to say, hey, we're done taking that penalty. Right? So we need some way of interacting with that lost turn method here. So I'm going to insert another getter here, right? We definitely need getters for lost turn and track. We can get the track, we can get the lost turn. That's good. And let's add a setter for get lost turn. Right, we should be able to change that value for lost turn here. Okay, you tell me lost turn, I'll set it. Okay, in this case, that way in the game loop, we can say, okay, if they lost a turn, skip them and then set lost turn to false because they've lost their turn. Right, we successfully made them skip a turn. And we need ways to interact with that. We need ways to set that value, and it all has to happen in cart because what we have is a list of carts. Right? We can't have something specific to the subclass as a method because then we won't have access to it. Remember, because when we're a type of cart, we only get the base class methods. We can define the method, sure, perfectly fine, but we can override its behavior if we want to in the subclasses. That's how motorcycle gets to spin out. Right? Then the game loop needs to check, hey, if you have spun out, right, or if you lost a turn, we're going to skip you, and then we'll reset that and give you your turn back next time around. Okay? So banana drops the obstacle. Great. That's how we use it. And that should be good there. Let's see. So let's add another class here then. So let's add our class for, how about a shell? Okay, and shell is going to implement item because we're going to shoot the shell. So this implements item, and it's going to yell at us right away and say, no, we don't. We need the method. And yes, please, NetBeans, type some code for me. Okay, and what happens when we use the item? Well, we need to tell the track we're shooting a shell, right? So we tell track dot, I don't know, shoot shell. And we can tell it, either the position or we can get the position from the cart. Either way is okay. And now it says, oh, I don't have a method for shoot shell. Should we create a method? Yeah, please create a method. Let's go over to track. We'll take a look at our shoot shell method. Here we go. So here's shoot shell. So what shell needs to do is find out the starting position. So starting position equals the cart.get position. Help if you could spell that right. It's position here. And then we need to loop through. We need to find the next closest cart. Right? It shoots whoever's in front of us. The very next person. These are like the red homing shells, right? Or heat-seeking shells, whatever we call those. Right, so we need to find who's the very next person in front of us. Okay, so we need to loop through every cart. So we're going to say for other cart maybe? Other cart in carts. We could do something. Okay, so we need to see who's ahead of us. So if they're, or no, this is what, current position, I guess? If their current position is greater than our position, they're ahead of us. We need to find the minimum one of those. So we need the smallest position that's ahead of ours, right? Okay, so we're going to have the a cart to hit, or I don't know what next, nearest ahead cart. Right, sure, why not? So the nearest ahead cart. Okay, so if the cart dot get current position on track is greater than the current position, they're ahead of us. Right, this means they're ahead of us. Okay, then we need to see if they're ahead of us, are they the nearest one who's ahead of us? So we can check if my nearest cart, here, this should actually start off as null, because I don't know otherwise. So if the nearest cart ahead is null, is null, then, well, easy, the nearest cart ahead is the cart. Done. Right? If I didn't have one who was ahead of me before, and I found someone whose position was greater than mine, they're now ahead. Otherwise, right, else here, well, if that was not null, right, if there was already a cart, I need to see, is this one closer? So if the nearest cart ahead dot get position on track, if that's greater than the cart dot get position on track. Right, so if you're ahead of me and I don't have a nearest, you're not the nearest. If you're ahead of me and I do have a nearest, we need to see who is closer. So if the cart is less than that one, that means they're closer to me, then my nearest cart ahead will equal the cart. Does that part make sense? Okay. If they're not closer, then I leave the nearest cart as the nearest cart. And I keep on going through all the carts. When I'm done, I can check if nearest cart ahead does not equal null, then we'll call the nearest cart ahead spin out. Right? If we found a nearest cart ahead of us and it's not null, spin it out. That's how we shoot a shell. That's how the track manages the shell in the game. Right? And these are instant hits. There's no time, whatever. Okay, so it's going to find the immediate nearest cart and make it spin out. That's how we shoot a shell. Okay, so what shell does then is it calls track shoot shell for the cart. The cart that used that item, right, tells the item to go use, given itself and the track, and then it nulls out the item. We've got a little format here. Okay, so we see like cart talks to item, item talks to track, track talks to cart, whoever gets hit. So we see this whole chain of interactions happening here, right? All the ways that these objects are interacting with each other. Okay, so that's shell, and then we need mushroom. Let's add a new class for mushroom. Here, so mushroom will implement the item interface. That's item. And thank you, NetBeans. Write some code for me. Okay, well, what do we do when we use? So mushroom is going to give us a speed burst. Okay, so we need a way to make the cart go faster. Now, either you make the cart go its max speed, or you make the cart go above its max speed. Up to you. You know, I like the idea of it going faster than its max speed. So to do that, right, we need a cart dot, I don't know, speed burst. We need a method for it. All right, well, let's go write the method. And NetBeans, give me one. Generate a method in cart. Let's take a look at speed burst. Okay, well, what happens when we call a speed burst? Right, we're going to take our current speed. Let's say it equals now our max speed plus, I don't know, 5. Sure, why not? Right, we've used the mushroom. That gives us our speed burst. Okay. That's it. Okay, that's how we can get a speed burst. That's what mushroom does. Okay, so we've got our mushroom, we've got the banana, we've got the shell. Those ones are all done. Why is that one green? Oh, it's added. Okay, sure. Modified. Oh yeah, new file. Gotcha. That's it knows we're using Git, and it's being helpful. All right, so we did motorcycle. Motorcycle spins out. Let's do heavy cart next. Oh, heavy cart. All right, so heavy cart extends cart. Right, it's a subclass of cart. And right now it's upset because we are not calling the cart constructor. So sure, let's call the cart constructor. Give it a track, max speed, acceleration, on and on and on. Let's add our modifiers. Right, so heavy cart is -2 acceleration and brake speed, but +2 max speed. So max speed +2, acceleration -2, and brake speed -2. Okay. Now what makes heavy cart special? Heavy cart gets a second item. Right, so we need to set then second item equals null. And what we need to do is we need to override our add item method. Void add item. Given an item. And we need to change the behavior. When we go add an item, we're going to see whether or not we add it to our second item slot. Right, so the first thing we can do then, we can say if item equals null. Great, then, I'm sorry, this item, right? That's my parent class item attribute. Then this item equals the item. If it's not null, right, then else if my second item is null, then my second item can be the item. Okay, so we can pick up a second item. Then what we also need to do is we need to override our use item. Public void use item. Right, so what needs to happen in use item? Well, sure, check to make sure we're not null. Right, if we're null, nothing happens. I guess we didn't check that in cart, did we? When we use an item, let's see, where's use item? Use item. Use item, there we go. This little navigator on the left can be helpful. So let's make sure first that if item does not equal null, we can do this thing. Just a quick little safety check, right? If you try and call a method on a null item, you crash real hard and get that null reference exception. This is like just defensive coding here. Okay, cool. So then we'll come back to heavy cart. So we can actually, we're going to do mostly that same thing to start here. So let's come back to cart. I'll just copy paste here. Okay, if it's not null, it uses it. Then what we can do is we can set it to the second item. And we can take second item and make it null. Okay, so second item might have been null. And that's okay. If it was null, we've now set item to null because we used the only item we had. If we had a second item, now we said, oh, second item, you're now the first item, and second item, now you're null, you're empty. So we're able to change that behavior of how we use our items just by overriding those methods. Again, everything has to happen in the base class method, or there has to be a method in the base class that's getting called. Because the track could care less what type of cart we are. The track only knows that we're carts. So the only thing it can do with us is use methods that belong to cart. Now we're allowed to override that behavior. That's the beauty of polymorphism, right? It thinks we're all carts of the base class type, but we actually can override and provide specialized behavior of our subclass type. There's heavy cart. Okay? You folks keeping up so far? Now we need a light cart. Okay? Light cart extends cart, just like the rest of them. Now, polymorphism means I can treat a object as its parent class type, but then I'll get the overridden behavior. That's why in track we can say, hey, I have an array list of type carts here, of type cart. And I can use all of the cart methods on them, but if I've overridden it, I'll get the correct overridden behavior. Polymorphism is fantastic, one of those fundamentals of object-oriented programming. Hopefully you talked about in CIS 1500, but I'm hearing lots of hit or miss about how far folks actually got into classes and inheritance and object-oriented programming principles, like encapsulation, abstraction, polymorphism, inheritance, those sorts of things. Yeah, smile face. Okay, that's all right. So we actually were planning a meeting of the full-time faculty members who teach 1500 to get together and take some notes. So I'm new as of last semester, and best I can tell, I'm expecting more from folks in 1500 than has previously happened. But I don't think I'm expecting too much, right? Like the topics we're supposed to cover are the topics we're supposed to cover. I think it was not done well enough in other sections. So, that's a personal opinion, and I'll have some discussions about that. But yeah, talk to me about it for sure. I'm happy to get some feedback. So I know our amazing SI, he wasn't in the SI for me last semester, but he also does the individual tutoring through the ASC, which, by the way, go sign up for tutoring if things aren't making sense. The ASC, right here. We have free tutoring available through our Academic Support Center. And we have 2 amazing tutors that you can take a look at through the Orchard Ridge campus. I think Auburn Hills also has a CIS tutor, but I don't recall. I only know about the Orchard Ridge campus because I teach at the Orchard Ridge campus, so I'm a little bit siloed, unfortunately. We do talk in the discipline, but so Tim, our amazing SI, has individual tutoring sessions you can book, and Rika, who I've heard is very awesome. I think I've met her, but I'm terrible with names and faces and that sort of thing, also has individual sessions you can book for these classes. So that's another thing you can take advantage of above and beyond the SI sessions. Yeah, so please do that. And honestly, I'm a little bit self-serving here, because if we don't use the tutoring sessions, then they're not going to pay for tutors for CIS next semester, that sort of thing. Like if students aren't attending the SI sessions, they're not going to give me an SI next semester, that sort of thing. So I'm having a little bit of trouble in the 1500 class with students not going to the SI sessions, despite all of the questions I get and me saying, please go to these SI sessions. That's a great resource for folks to get some more questions answered. And I know the timing doesn't work for everybody, so like I'm never going to force it or require it, but take advantage of these things for sure. All right, where were we? Oh yeah, glad to hear Rika's really great. I've heard good things. Yeah, not sure exactly how that works, but yeah, go for it. It's Mondays and Wednesdays, 12 to 1. I think there's a different link though, so ask the SI about that. Not exactly sure all the details, but yeah, check with him. He's much more familiar with the process than I am. This is the first time I've had an SI for a class, and I think it's phenomenal because the college pays for that. So okay, you guys pay for it through your tuition dollars and through the taxes that you pay in the state of Michigan through our state appropriations towards higher education. It's not free, but like there's no direct cost, additional cost for using the service. Can I say that? I think that's a fair way to put it. Excuse me. Coffee grounds. Yum. Okay, so we're doing all right so far. So then light cart is a +2 to acceleration and brake speed, but -2 to max speed. So our light cart here then, where it's going to extends cart here. It should complain that we don't have a constructor. Good. Yes, we need the constructor. Please make one for us. So max speed was -2, but acceleration was +2 and brake speed was +2. Okay? And what happens special for them is they get different behavior for the enter bend. Public void enter bend, given a bend. Okay? Right? And the rule for light carts, this totally arbitrary, I'm just making this stuff up as we go, right? Was that they get an extra chance to break before spinning out. So we should see, so we can check. So we'll say, hey, if our current speed is greater than the bend.max speed, bend.get max speed, then we want to break before we spin out. So let's apply a break. Let's break here. So we're going to try, but I might not want to break the whole amount, because if I'm only going 1 over and I could break like up to 10, I don't want to go 10 units slower. I only want to break down to the max speed. And I think, what was it? If we only checked if we're greater than, right? For entering a bend. So if we're equal to the bend max speed, we're okay. So what we're going to do here then, we're going to try and break. We're going to say we're going to break, breaking, that's right, breaking, because break was reserved. We want to break, well, the difference between the get max speed and my current speed. Okay? If the max speed is 10 and my current speed is 9, I only want to break 1. Nope, that's backwards, sorry. Other way around, current speed minus the max speed. So if my current speed is 11 and the bend max speed is 10, I only want to break by 1. Okay? That's it. So this gives me one last chance to break an additional time before I take the penalty. And then, if it's not enough, right, and this is okay, if my current speed is 100 and the bend max speed is 10, right, breaking is going to say, oh, I'm only allowed to break up to that max break speed. So no problem there, right? I don't need to do any of that additional logic. Then what I want to do is I want to do the enter bend thing again, so I'm going to call super.enterBend, because I don't want to have to repeat the logic, right? My super class, my cart class here, knows how to enter a bend. If my current speed is greater, I'm going to spin out. Again, sure, it's 2 lines here. I could copy paste and feel bad about it, but if you copy paste and have the same code in your project twice, you should feel bad about yourself. So I'm going to try and avoid feeling bad about myself. So I'll just say, hey, super class, go do your thing. Remember, this super is a great way to say, hey, if you want additional behavior but then do the same thing, or do the same thing and then specialize, do an additional thing, that's all well and good. So I'm going to enter the bend. If I'm going too fast for it, try breaking one more time. Then make the superclass version enter bend happen. We're going to say, oh, sure, if my speed is greater, I spin out. I lost my turn. Or speed goes to 0, that sort of thing. Okay? How are we doing so far? So we did light carts, we did heavy carts, we did motorcycles, we did cart, we did track has the carts along with their position, total distance, how far to the end, a series of bends. Each bend should have a max speed. If it goes into the bend, okay, you have to be able to figure out distance until the next bend for a given cart. Okay, sure. So let's look at track. We need a couple more things in track. So I'm not going to do this position thing here, because we added a position attribute to cart. Right, we're going to have a list of bends. Items here, again, this was a little bit tricky because we need to know where the items are, and we could either go add something to the item interface that says, hey, you need to know what your position is. I kind of like that. We could do that sort of thing. Yeah, I kind of like that. So let's go to the item interface. Let's change that here. So we're going to say an int get position on track. We'll say, hey, if you want to implement the item interface, you need to have a position on the track. Sure, it's all well and good. So now let's go to our classes that implement it. And let's go say, oh, okay, let's implement that abstract interface. And we need to then return position. Okay, well, we don't know what a position is yet, so we need an attribute for that. So we'll create a variable for position. No, not local, sorry. We want to create a field for position. Okay, well, if we're going to need the position, we need to have a way to set it. So we're going to insert a constructor that takes a position. So when you create a mushroom, you tell it where it is. Okay, and we can use that position later on because we can get the position out. So I'm going to take this get position on track. I'm going to add this to each of these here. And we'll add that to banana. Okay, and then we will do the same thing here. We need to add a field for it, for position, and we're going to add the constructor. Again, let the tool do the work for you, right? Don't do more work than you need to. Does that work smarter, not harder? Okay, sure. Now banana has a position. So you make a banana, you have to tell it where it is on the track. Sure, we can use that. And then same for shell. So sure, add that as a field, add a constructor. That takes a position. Awesome. Okay. Cool, so now all we need is a track here, right? Because we added a position attribute to the item classes. We added a public method to the interface that forced the subclasses to be able to tell you what position it is, okay? We have that sort of thing. So now what do we need then? When we make a track here, maybe we make a track constructor. Well, what do we want? Do we want them to pass the list of carts to us? Do we want them to pass a list of bends, pass a list of items? We could do that, sure. Or we could have methods for them to add them. Either way is okay. So I'll just go this way. We'll just ask for them in the constructor. So you tell me the carts that are on the track, you tell me the bends that are on the track, and you tell me the items that are on the track. Okay, so if you tell me those things, I will make the track. Right, that's setting up the track. So this carts. Now, do be careful here. When we do this, this is actually technically bad form, because whoever created this array list of carts still has the reference to it, and they can go and add carts or modify carts directly. What I probably should do is make a copy. Remember, we should make copies of things. Now, the problem is I don't really have a good way to make copies currently. We talked about copy constructors last project, right? Where, which one was the card class had a copy constructor, but I didn't ask for one. Copy constructor, so, I mean, it's the right thing to do, but we haven't done it, okay? And that's okay. So this dot bends is the bends, and this dot items to pick up is items to pick up. Okay, then we also need to initialize this, right? The constructor's job is to give values to all of our attributes. So obstacles on track equals a new array list of type integer. Okay, we need to create that so that we can use it later on when we drop obstacles on the course. Right? Okay, then what we're missing here, right, is we need the way that carts have to take turns, right? We need to see, hey, did they cross a given position, right? Well, I don't really have a way to move cart, right? Cart has current speed, but it doesn't actually move at all, so we need a way to move the cart, right? So we need a method for move, like void move. That takes its current position, or position, plus equals the current speed. Right, so to interact with cart, right, to make it move, we're going to call the move method. Right, the idea, before we call move, we need to ask in whatever part of our program is managing user interactions, probably in the project 3 with the main method, we'll say, hey, what action do you want to take for this cart? Is it going to accelerate? Is it going to use an item? Is it going to brake or braking, decelerate? Maybe we should call it decelerate. That's fine. It's probably, I mean, not too late for that, but sure. Okay. Okay, so move, and then we'll change its position. Right? And maybe, maybe spin out, because if we enter a bend and we've moved 10, if we move past the bend, changing our speed to 0 seems a little silly. We should really like spin out at where the bend starts. Maybe. Again, this was probably optional. I didn't ask for anything like that, but maybe we could change its how it spins out. Maybe we could give it a location that it spins out, and we could reset that location if it needs to. And we probably also want to check after we're moving. Then we should check if my current speed is greater than the max speed. Let's reset. Speed equals max speed. Right, because that idea, the mushroom can make us go faster, but then we should bring that back down here. Right, so we'll move, and then we'll reduce our speed back to max after we've moved that mushroom burst. So if we use the item, it'll increase our speed above max, and then we can move, and then we should decrease it back to max. Right? You get like automatic braking at that point, right? Okay. We all right so far? So this idea we can move then. So then in, I don't know, track maybe, we're going to have a, I don't know, public void move each cart. So it's going to take all the carts. It's going to get their current position. It's going to move them, see where they landed, where they ended up, see if they ran over any obstacles that are on the course, see if they entered any bends that were on the course. Right? We could do all that, sure. So, yeah, we'll say for cart in carts. Let's go move them. So we have a int current position. Current position equals cart.get position. And then we'll call cart.move. Right? Move the cart. And then int for moved position. I don't know, sure. Cart.get position on track. So now we know where it started and where it ended for its move. Now we need to go loop and see if did it enter any bends or did it run over any obstacles around the track. Okay, so I like that idea. I'm going to change spin out here. Let's see, where do we use spin out? Let's see. So spin out is going to take a int position spun out. Okay, and it's going to set the position on track to the position that they spun out. Okay, so if you spin out, we're going to reset you back to where you spun out. So now let's see. So cart, that should be fine. Now track is unhappy. So when we spin out, where do we spin out here? So spin out. So when you get hit by a shell, you should just spin out in your location. That's the nearest ahead cart.get position on track. You spin out in your exact spot, right? No big deal. If they run over a banana, that's what we're about to do here. Right, we'll deal with all that. Okay? So then if we enter a bend here, there we go. That's right. So when we enter a bend, we spin out at the bend.get position. Okay? And I think we overrode enter bend in light cart, but that all happens here, right, in the superclass, right? We call superclass, so we're perfect there. No big deal. Okay, so then track needs to say, all right, sure, we've moved. Now we need to see if we entered a bend with that move. Okay, so we need to say for bend in bends. Sounds like a Dr. Seuss book. Bim, bends, bims, broom. Right? That's Fox and Socks. That was like my favorite Dr. Seuss book. I love reading that one to my kids. All right, so for each bend, we need to see if they crossed over it. Right, so if the current position is greater than the bend.get position on track. I'm sorry, no, if it's less than the position. So if we start before it and we end after it. Yeah, let's say. So if we start before it and our move position is greater than the bend.get position on track. Right? So if we started before the position and we ended after the position, or maybe even are equals to. I don't know, where do we, one of these is probably right. So if you start at, let's say if we start at the bend, if we're less than or equal to the bend, and then we move beyond it, we're going to spin out if we need to, right? So if that happened, then we'll say cart.enterBend, the bend. Right? So look at all the bends. If we started at or before the bend and we ended after the bend the start of the bend, again, I guess, I mean, bends might have a certain length, but we didn't get that far. So we'll just say a bend is a single unit. Sure. Maybe these are all like super twisty terms or something, right? Cart, enter, bend. That's it. Okay? Then we have to do the same thing with our items. Right? We'll see if we run over that item. So we do all the bends, and then we can go. Now, a cart might have gotten pushed back here. So we do need to be a little bit careful. So we're going to do this. I'm going to do this one more time here then. I'm going to leave their current position, but I'm going to say their move position then is in case they spun out in the bend. we're going to get their moved position again, get their new position. Okay? Then we can say for integer, I don't know, obstacle in obstacles on track. Same idea here. If the current position is less than or equal to, and that's my obstacle now. It was a get position on track. Get. Oh, I'm sorry. That was just an integer, right? Obstacle on track is just an integer. So for each obstacle, right, we just check, hey, are we less than or equal to it, and do we move past it? If we did, then the cart spins out. Spin out at the obstacle. That's its position. So if there was a banana at position 7, we started, say, at, 5, and we moved to 9, we're going to spin out at 7. Then what has to happen, though, right, only one cart gets to spin out per time. We need to actually now remove that from the list. And that's actually really messy. That's unfortunate. Because now we need to remove that obstacle. Let's do this. That's okay. And you should only ever spin out once, right? So this should probably break our loop. Right? Once, you're only allowed to hit one banana, right? Because you're going to stop, right? That idea. So we'll break, and then we also need to remove that here. So we're going to take our obstacle on track, and we're going to call remove, and we're going to remove the obstacle. Right, so if we ran over banana at 7, let's take 7 out of the list of obstacles on track. So we break. Okay, that solves our problem then, because like you can't use loops and be modifying. It gets really upset. Move the banana. Okay. All right, I think that's it there then. Give that a little format. And that's probably not too bad to go on one line. This one needed 2 lines. Right, so then what happens then in the game loop, right? We need to loop through each cart. Do we have a way to get the carts back out? I don't know if we have a way to get the carts. We don't. We need a way to get carts. Okay, so we need some methods. Well, let's add a bunch of get methods. Why not? And again, you got to be careful with gets, because if we give them back the array list, they have full access to add or remove things. So you might want to consider copies. But again, it wasn't anything we asked for, so that's okay. So we'll get the list of bends, we'll get the list of carts, get the items, get the obstacles. Sure, why not? Add a bunch of gets. Oh, and the other thing cart needed, then track needed, right, was a way to tell how far to the next item, right? A method to return the distance until the next bend for a given cart and the max speed of the upcoming bend. Right, well, we could just give them the bend, I guess. The next bend. Sure, let's do that. So we'll get the next bend for cart. Let's add that. So we'll add a method here for public bend, get next bend for a cart. So if you give me a cart, right, I'll go, oops, public here, spell that right. I'll go find the next bend and give it to you. We'll say for bend in bends here, we need to find the next closest bend. Right, so then we'll have a closest bend, so bend, closest bend, similar to what we did when we were shooting items, right? It starts off as nothing. So if the bend.position is greater than the cart.getPosition, means it's ahead. Then if the closest bend, is that closet or is that closest? Close-est, not closet. The closest bend does not, if it equals null, then that's now the closest bend. Okay. Otherwise, we'll see which one's closer. If the closest bend is get position on track is greater than the bend.get position on track, we have a new closest. The closest bend is the bend. Okay. When we're done, we can return the closest bend. We do have to be a little bit careful here. The closest bend might be null. There might not be a bend ahead. So whoever's calling this method is going to need to be careful that they could get back a null. And that's okay. We would manage that in the game loop. Okay? And now the game loop, it's not so bad, right? Once we can get carts, we go through and we say, okay, cart, what's your choice? Accelerate, use item, brake. And here's the next bend. Or we can give some information if we want. And we could tell them the current speed. We could tell them their position on the track. We could figure out place values, all sorts of other things if we wanted in the game loop. I've got 7:10 on the clock right now. I've been talking for quite a while, and I'm out of coffee. But I think we've satisfied now all of the main requirements here, aside from the game loop itself, right? And we could do that later if we wanted, or another. I don't need to tie you up all there. But the idea right now in Project 3 that actually uses the main method. This is where all of our all of our interaction should happen. So user interaction happens here, right? The idea is that our classes are beautiful and self-contained, and they don't rely on system out print line and keyboard.next line. That is not the class's job, right? A class should not care where it gets input from. Now, there might be a case, yes, this class specifically is only meant for doing things at the console input, sure. But ideally, right, if we want our classes to be reusable, we encapsulate all the details, we give that abstract public interface for them to interact with, right? We could use it in any sort of application. If we wanted to, we could use all of these classes when we write a GUI application, right? We don't need to have console input, system out print line stuff happening to use these classes if we avoid that here. So all the user interaction has to happen here in main, where we expect to have console input output here. Remember, if you build a web application, no one is seeing your console output. If you build a mobile application, no one's seeing your system.out.print lines. No one cares because they can't see it. Right? So we want classes to be independent of how they're going to be used. That's the goal with classes, right? We want them to be reusable. I don't want to have to redo a bunch of work to take this console text-based game and turn it into a graphical user interface game. We're not doing that for the final project, don't worry. There wouldn't actually be enough work there. That'd be too easy, if you believe that or not, to like pop up a bunch of user boxes and click a bunch of things and draw pictures. I don't know. We're going to do something more interesting, hopefully. Okay? But all that interaction here happens inside of main, or things called by this method starting in main. Right? The rest of the classes happen. Right, so we commit all this to GitHub. And we'll take a break. We'll get some more coffee. I'm going to take some more cold beds. And we'll come back in about 10 minutes or so. This is 21:51. Here we go. We put on some music here. All right. So how do you feel? Is that, I mean, and again, there are lots of different ways to design the solution. That's not the only way this had to happen. It didn't have to have this method, called this method, called this method, called this method. Right? We can design them lots of different ways. That's the art of it, which I think is the fun part. Right? As long as it gets the job done, we're happy. Now, some things might be more efficient than others, and that's, we can learn more about that later in other classes as well. All right, so why don't we go on break? We'll take 10 minutes, come back, say, at 7:22, and we'll pick it up with exceptions today. Hey, folks. All right, perfect timing. Song just ended. All right. Oh, I still got 1 more minute on break here, so we'll give it just a second. I think I committed all that to GitHub. We should be all set there. And yeah, I think we're good for now. Let's see. Yeah, okay. Now I think we're ready on our time. So just to like, we're not going to actually write the game loop, but I guess we would say, you know, like loop through each cart, get the action, you know, item, accelerate, break, that sort of thing, and then we would call track move carts, right? So each cart would pick, they would do their thing, you know, pick what they're going to do, and then we'd make the cart do that change. So if it accelerates, it will increase the speed, and then we'll call track, and then we call track that move carts, or something like that, whatever our method was there. But to create the track, we need to create all the bends, we need to create all the items, we need to create all the carts, right? So we would create carts, bends, items, has to track constructor, yeah, and then just loop through and go, oh, track didn't have the ending position, right? I guess we needed an ending position as well, right? So track probably needs the int end position, right? So we should set end position, right? That's, you know, when the game's over, that sort of thing. This dot end position is the end position. We can add that as an attribute here. Create a field. There we go. So maybe we'll also have like a, you know, is game over. We can do that. Public boolean is race over. And what we can do then is we can say, for cart in carts, if cart dot get position is greater than or equal to the end position, we're going to return true. If we've looped through all the carts and no one's there, we're going to return false. Right? And that way the game then can loop, right? Like while track dot is race over, or not, right? Well, not is track over, loop through, move the carts. That sort of thing. So that kind of sets us up for where we need to be for that game loop. Again, haven't made all the calls, haven't made all the objects yet, but we could go through all that. If you wanted to ask people, hey, what kind of cart do you want? Do you want a motorcycle? Do you want a heavy cart? Do you want a light cart? Sure, we could do that, and then create that in the carts list. We can add a bunch of bends. As customizable as we want to be. And I switched off of coffee and I switched to Coke Zero here. So that should be fun, right? All right, let me pull this up here. So we're going to jump into part of, I think it's chapter 10, and talk about exceptions tonight. The advanced file I/O will save for next week. So we still have something to talk about next week. Okay, and we're actually going to do a lot with file I/O. Our final project will use some file I/O as well. File input output. Sorry, file I/O. I/O. Bleh. Say that 10 times fast. Okay, just pulling up our, oh no, that's the wrong chapter. Shoot, what chapter is it? I guess I should just look at the syllabus. Didn't I have that open over here? Didn't I have the syllabus? Yeah, let me see what chapter it is, because I don't remember. It's not at the top of my head. 12, maybe? 10 was inheritance. Let's see. 11. Okay, 11. I was close. I'm just going to make sure, pull up the slides, make sure I don't go too far off track. So again, hopefully you're actually reading the book, because that's a super helpful reference, and that's why we have a textbook. That's for your reference, sort of thing. Okay. So, start up a new project. We'll close project 3 down. Oh, that's right. We added some more comments there. So this is, add game loop comments. Or, I don't know, pseudocode. Would you call that pseudocode? And it's close. It's codey-ish. What did they add to track? Oh, we added the end position, right? For game over. Race over. We can also track like first place, second place, third place, that sort of thing. That might be a nice way to do it too, because if we're tracking places, we know shells would only hit someone who's ahead of us in place value. But, we've got lots of options. There are lots of ways to track it. I'd call it pseudocode. Thanks, Sticks. Appreciate that. Okay, so we'll close this one down. Close. Sudo. I always make sure that I let autocorrect or spell checker tell me, because I can never remember how to spell things. All right, let's start a new Java application. This is for 2151, winter 2021. This is exceptions. PS, yeah, definitely a PS. And there's pseudo, the silent P, because English is English. Excuse me. All right. So you recall way back when, keyboard, let's make a scanner equals new scanner given system.in. Wow, this Coke Zero is bubbly. Whew. And we'd say, enter a number, and then we would get an integer. Number is integer.parseInt given keyboard.nextLine. Right, this rings some bells, right? Just getting some user input. Import scanner. And then we would, I don't know, this out, your number is, what's the number? Sure. And this is all well and good, right? And it runs, and we can enter some numbers, and we get some numbers back out, and we would do arithmetic or something more interesting with it, right? Do you remember, occasionally, what would happen when you enter a number, say like 10, it says exception in thread main, java.lang, number format exception for input string 10. Wow, this red puke, right? This is called a stack trace. This means an exception happened, a bad thing happened, and we didn't deal with it, and our program crashed. Now, I don't know about you folks, but I apparently am an irritable, impatient sort of person, and nothing upsets me more than when I'm using a program and it crashes. I don't know why. Maybe because I'm a software engineer and like I feel like that shouldn't happen, and then whoever wrote it was just lazy. As a actual production application, crashes shouldn't happen, right? And we're going to learn how to deal with it so we don't crash, because we don't want to piss our users off, right? If they're using our application and it crashes on them, they're going to think it's a terrible application, and they're not going to want to use it, and they're going to complain about it, and all sorts of bad stuff. Right, so what we want to do is we want to handle this exception. So when an exception happens, we can do something about it. To do that, we put it in what's called a try block. We're going to try something. And you try things that might cause exceptions. And what you can do is you can catch exceptions. So in our case, we want to catch the number format exception. So it's type, catch number format exception, and we'll just call it exception. Okay? And here we can say, that's not a number. Please try again. Okay? And this is going to upset with us. It doesn't know what number is, because number was defined inside the try block. Remember, the scope is the try block. So we could either put this inside the try block, or we could define it outside the try block, try setting the value inside the try block. Either way is okay. So let's go this way then. So we'll say int number, and we'll say number equals inside the try block. Not all the things that the user can do to screw it up. It has to be inside of try if you want to catch. So you can't have a catch without a try. Okay. So let's run this one. Uh-oh, there's an error. Where's my error list? Why can't, oh my goodness. Oh goodness. Wow, I lost my error list. Errors? No. Split? No. Toolbars? No. Oh my goodness. I turned it off somehow. Where did it go? Where's my error list? All right, I'm going to go Google it because I'm confused right now. NetBeans show error list. Compiler errors. Show me the errors. Action items? Is that it? Action items window? I don't think that's it. Yeah, I Bing it. It sounds funny, right? It's Googling. That's the technical term for it, right? My goodness. Windows. There we go. It's in our Windows, right? Tasks. Is it tasks? Is that it? No, that's not it. Forget that. Windows. IDE tools. Oh my goodness. Folks. It's one of those days. It's one of those days. Setting up to Wumbo. I don't know what a Wumbo is. Reset Windows. Did it crash it? Did I really need to close it? Okay, there we go. A reset. There we go. Okay. Does that do what I wanted? Let's see if it'll build now. Run. No. Where's my error? Doesn't it? Okay. Sure, I know where, I see it right over here. Okay. I'm confused. All right, right here, variable number might not have been initialized. Uh-oh. So it's not going to let us do this because we declared number and we didn't do anything with it. That's a bummer. Well, what do we want to do? Well, we could put them inside of a loop now, right? We could say while, right? So let's put this inside of the try here. Isn't the tab next to exception in the bottom window? I thought so. I don't see. This is like the build log, and this is exceptions. That was just telling me that it failed. I think I don't get the list of why it was wrong. I don't know. I'm confused. That's okay. I'm going to blame it on the cold, but it's probably I'm just stupid, and that's okay. Because the red line's right here. But I thought it gave you a list of them. I'm so confused. Is there another tab down here? No? I really thought it was somewhere. Action items? Ah, action items. Look at that. There we go. Is that it? Action items? Sure. Show action items. Current edited file only. I don't understand what all these ones are. That's okay. Group items by category. We want to ignore the warnings. Let's see, can I filter just on pilot errors? No? No, that doesn't make those go away. Never mind. All open projects, current project. That's fine. I'm just going to hide the warnings. There's my error. Okay, I found it. I guess. Well, so what do we want to do? Let's put this in a loop then. Right? We'll say while what number is null? Okay, is that? No, we can't do that. That's ugly, right? Because it's not a reference type. While true, and then break. That's ugly too. And then it's still, oh, it resolved our error here, but this is ugly, right? But I guess it's okay. It's one way. I don't recommend this one. I think that's probably kind of terrible, but that's okay. That little format. Okay, and then I can just keep on going over and over and over and over and over. 10 ASDF, blah 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 blah. 10, and I get my number. Right? So this is the try and catch. So if we know something could throw an exception, we can put it in a try block so we can handle that exception and do something about it. Whether or not it's just spit out an error and make them try again, or whatever our choice happens to be. Okay. We could also set number to like negative a bazillion and check as long as it's a negative a bazillion. Right? That sort of thing is like a sentinel value that we don't expect, but it's relatively vague, and I'm saying enter a number. Oh yes, there are lots of common exceptions. You can have multiple catch blocks, is how this works. Vanzo. And yeah, there's a list of exceptions out there. So in the Java API exception, check this out. Look at this. This is so cool. The Java docs for 8, version 8. Exception is subclassed by ACL not found, activation exception, already bound exception, application exception, AWT exception, backing store exception, bad attribute value exception, URI exception, property veto exception, non-invertible transformation exception, last owner exception, invalid preference format exception, GSS exception, data type configuration exception. Jeez, yes. Yes, exception is a class that we can extend. All of these classes extend exception. So we want to make our own, we can, which is awesome. I'm fond of, is it value? Invalid argument? Where is it? Invalid something, I don't know. We get all sorts of fun ones, okay? And you can pick. So what catch does is it says, is it specifically this? And through the magic of polymorphism, anything that subclasses this is also a this. Right? So we could just catch a generic exception type. The superclass exception that is the mother of all exceptions, right, is fine. Now, what it's telling us here is, hey, it could be replaced with multi-catch or several catch clauses catching specific exceptions. Generally, this is considered bad form, right? Because if we know what exception type, we should be specific about that. But sure, so that's, let me undo that. So we'll put in here catch exception superclass type. Class is considered bad form. Okay. The other thing you can do is you can have more than one catch block. You can also catch then another kind of like invalid, I don't know, invalid algorithm parameter exception. Oh my goodness. I don't know. Come up with anything you want here. Invalid name exception. There we go. Invalid name exception. Exception. And we could do a different thing. So you're allowed to have multiple catch blocks. It's telling me, hey, this is never going to happen. Right? It's smart enough to know that parse int is going to throw a particular type of exception here. Right? So we do need to be a little bit careful with that. But you can have multiple catches, and what you want to do is you want to go from specific to general. Okay? Most specific to most general, because the first one that catches, just like an if, else if, else if, else if, else if block, the first one that runs, runs, and they're mutually exclusive. Okay? So that's what we can do with these. So you've seen stuff crash before, and this will keep it from crashing, right? Which is really nice. We don't want our programs to crash. That upsets our users. Okay? The other thing we can do here is we can, when we write a class here, let's write a class like, I don't know, coffee. Sure. And coffee will have a int for ounces. We'll go milliliters. Milliliters. Public coffee. A constructor. Here we go. Let me make it write itself. I'll insert some code. Insert a constructor that sets milliliters. Great. And then we'll have a, I don't know, a void method for drink. Int milliliters to drink. Okay. And what we can do here, right? The idea is if you go to drink this coffee, we're going to take my milliliters minus the milliliters to drink, or minus equals, right? Subtract. Now the problem is if you try and drink 1,000 milliliters and you're only a 500 milliliter mug, because that's sad to only be half a liter of coffee, bad things should happen. Remember, classes are responsible for maintaining the integrity of their attributes. That's the idea. We're encapsulating all of our details away, and we're going to maintain our good, valid state. With our public methods, that abstract public interface we expose needs to make sure we don't get put in a bad state. Okay, so we should actually check. We should say if the milliliters to drink is greater than the milliliters, what do we want to do? Well, we want to tell whoever called this function they just did a bad thing. We don't want to do system out print line. Remember, we talked about classes should not print line. That's not the class's job, unless it's a very, very particular class. But in general, we want our classes not to be specifically tied to one type of input and output. So what we do is we throw a new, and we come up with an exception. What is it? Invalid, illegal argument exception. I like that. Illegal argument exception. And then we give it a message. We say you can not drink more milliliters than are in the cup. Right? Sure. We give it a message. Okay? So what we can do over here then, right, we'll make a cup of coffee. We'll make coffee cup equals new coffee. And we'll say, hey, there's, I don't know, 500 milliliters in this coffee cup. And we're going to call cup.drink. And let's drink 1,000 milliliters. Okay? Ooh, let's drink number. There we go. Number of milliliters. Whatever that number is. So we'll run our program. Okay? So if we drink, say, 750, we get an exception in thread main. Illegal argument exception. We even see the message here, right? You cannot drink more milliliters than are in the cup. Bad things happen. So what happens when you throw an exception, your code stops. Hard stop right here. Nothing else happens. If we don't throw an exception, then I can take my milliliters minus equals the milliliters to drink. Life is good. Okay? It's all well and good. But if we throw an exception, code stops. So stops executing at the exception. Right? This is the way, exceptions are the way that classes communicate with people using them. Right? If an exceptional thing happened, you did a bad thing, and it violates the integrity of my class, I'm going to throw an exception and say, hard stop. Either handle it or crash. And if you crash, you suck. I mean, okay, sorry. I'm a little particular about that. We're learning here. We're learning, okay? No offense. No offense. Let me get that a format here. Okay? So if it's not true, we don't throw the exception. We just take away the milliliters. Perfectly fine. And then we might say, I don't know, cup your coffee has, I don't know, some number of milliliters, cup dot get, oops, we didn't have a get method for it. Well, so your class here, like the class coffee, it has no control over what was passed to it. But if you pass an invalid value, then we're telling it, whoever called that method, no, you did a bad thing. So the class needs to maintain its integrity and make sure it always has valid values. The person calling or the code calling drink needs to handle the exception and deal with, oh, I did a bad thing, I need to fix it, or crash. Right? Like, parse int, the goal is not to crash our program, but parse int, the only way that it can tell us that it didn't work is by throwing an exception. So if we try and parse something that is unparsable, it throws an exception. Say, well, can't do that. You know, number format exception, whatever it happened to be, right? Yeah, a number format exception. That's invalid. Can't do it. A bad thing happened. So exceptions maintain the integrity of our class. It says, nope, can't do it. So if we try and drink too much coffee, we throw an exception. We have to handle that. So, oh, that's right. I was going to go and add that get method here. Yeah, you're telling whoever calls the method, and it doesn't even have to be in main. It could be a class calls another class, and that class would have to handle that possible exception, right? All the way on down through the line. Wherever that method gets called that could throw an exception, we need to be ready to handle it. Get milliliters. Okay, sure. So if we give it a good number here, like say 50, sure, we have 450 milliliters left. Sure, we'll put that on. So
I just have to tell you, I don't think I'll be after playing the D&D, so
all right.
tell someone to take my place.
Okay, we'll do that.
And make sure to tell me what happens now.
We'll do. Yeah, sorry you're not feeling good. All right, milliliters remaining or something. Milliliters left or something like that, sure. And add in some spaces, make this all nice and pretty. Yeah, we're creating our own here. Most of the time, I'm a fan of using existing exceptions because like they have almost everything out there already. And illegal argument covers lots of things. If you want, you can make your own exception, right? We could make another class that extends exception. We wanted like some custom exception here. We would be an exception, and we extends exception. Okay, cool. And we can use custom exception if we want. There's a couple other things you could call the constructor to pass a specific string message if you want. Remember, here in coffee, we were able to say, hey, here's a message. Here's a particular error here. You have to do a little bit of extra work there with creating the exception or the calling the constructor. So public custom exception, given a string message, super message, something like that, I think. Yeah, I think we just handed the super class. So this is optional. But if you don't do this, you can't use custom messages. You want a custom string message on the error. Okay, you can do that sort of thing. Okay, so the whole goal here is we use exceptions for a class to communicate that a really bad thing happened. The year of the end of times? Is that the terrible message that happens? Your custom message? Yeah, when we run out of coffee, it's a bad sign, right? Running out of coffee in your cup is just, you're having a bad day. And then you switch to Coke Zero. All right. How are you feeling so far? That's kind of the gist of exceptions. There's a lot more to it we can get into. But the idea is we need to, whoever called the method, about the metric system, what year is it? Oh, I missed that. Yeah, we should always use the metric system. The imperial system is terrible. Right? Trying to teach my kids, like, hey, there's 4 quarts in a gallon, there's 2 pints in a quart, there's 2 cups in a pint, there's 12 tablespoons in a cup. Like, this is nonsense, right? Like, just use milliliters, please. Right? There, pounds aren't so bad, at least, but there's 16 ounces in a pound. Why do we have to know this thing? Why are there 5,280 feet in a mile? Why can't we have a kilometer? Right? Which is 1,000 meters, which is so much easier. Right? If it's a base 10 measurement system, life is so much easier. Yeah, our imperial system is stupid. Yeah, if it's a known error, we want to handle it on your own. If there's something else, you throw the error, tell the user they're trash. I mean, ideally, our program doesn't crash, right? But, this is the way that the classes make sure that they don't get in bad states. And one of the things you can do is when we go and call methods, right, we can force them to be caught. Runtime exception. So let's see, error and exception. Yeah, so errors are just like bad Java internal things. Don't worry about those crashing typically. But the hierarchy of exceptions are like things while we're running. Right? We should do something. We want to try and catch it. And in the try block, the code stops when that exception runs. So if there's an exception here, break never runs because we jump right to catch. Okay. When we're doing file I/O stuff, like when using scanner to read files, remember exceptions could happen. So previously, I think we had scanner in here before. If we wanted to make a file, we might say, hey, let's spin up some file here. We'll say file, some file equals a new file, test.txt. Right, fine. And then if we said scanner file reader equals a new scanner, given the some file here, we could go and read it. Right, remember this from 1500? Add an import, sure. Equals a new scanner, sorry, new scanner. And now it's yelling at us saying, hey, unreported exception, file not found exception, must be caught or declared to be thrown. So what we would do in 1500, we say, oh, sure, add a throws clause. Tell Java, yeah, I know this might crash, pass the buck, I don't care. We're not doing that anymore. So we're going to try. We're going to say try here, try this thing. And then what we can do is we can catch the file not found exception. And we can print out, I don't know, sure. We'll just do the exception dot, is it get message? So get message here is like the nice way of getting that message back out. So I don't have a test.txt, so it should crash real hard, but that's okay. Not a big deal. Right? System cannot find the file specified. So I've given a nice message. I didn't crash. Yep, and then the last thing we do with blocks is there's a try and a catch. You can also add a finally here. A finally block will run at the end of the catch or the end of the try. Either one, it's guaranteed to run. Oh, that's really sad, 27 or TTV. Yeah, we were doing a whole project on files. Again, it's I don't know, it's a learning curve and trying to understand what all everyone is doing and how they teach it and those sorts of things. Like everything that's standard is in our course descriptions. It's like catalog in our course descriptions. This is the only thing that's standard. And the idea is we can teach it really any way that we think is best here. But the things you should learn, right, are all of this stuff here. Basics of GUI. Didn't it say something about files? Fundamentals, techniques, debugging, programs, iteration, data types. Oh, input and output. Yep, input and output. That's files here. Input, output. Didn't you have me for 1500, Mark? Am I remembering wrong? The username looks familiar, but it might be because we've had 10 weeks already. I did the silly text-based adventure game, right? The terrible text-based adventure game. Yeah. So we spent some time on it. Maybe not enough. Oh, okay. I'm sorry, Mark. I'm remembering badly then. Okay. So the finally block will always run. Finally always runs after either the try or the catch. Excuse me. Remember, when you're working with files, you open them, you rewrite them, and then you close them. We'd call file reader. Shoot, nope, that's we don't have that reference there. Yeah, there's nothing to close here at that point, right? But usually, like if we're dealing with files, we would always close them here in case some other exception happened. Less than one class period. Oh dear. And GUI stuff? Seriously? That's definitely wrong, because like you should be doing GUI stuff. There's supposedly a standard project, which I thought was just totally silly, for using a polite word here, that had everyone make an ice cream shop, and you could pick what type of cone and what flavor ice cream and all these sorts of things, and it would give you a total. I thought that was a stupid project, so we did something more interesting. But again, I'm still learning a little bit here. Maybe I have some different expectations, but that's okay. We'll figure it out and find a good level set base for where this should be. But I've been adjuncting for years and years before I was a full-time faculty member, and that's how I would always teach it, as an adjunct as well. So I'm still a little confused, but that's okay. We will get there. We will get there and try to level set all that. So, okay. Exceptions and classes. Yep, we got all that. That's good. You can handle multiple exceptions. Yep. Okay. Try catch finally. Finally always runs. I think we're pretty good. You can actually, in later versions, you can have different types of exceptions at the same time without having to repeat your blocks with a pipe operator. That's crazy. So like illegal argument exception or something. That's really crazy, this pipe notation for multiples. The pipe to have multiple types. Multiple exception types. Or just use multiple catches. He did that himself during the lecture. Okay, you didn't do it yourself. That's unfortunate. I'm sorry. Sorry, folks. Yeah. All right. Yeah, I think we're pretty good then. And we'll talk more next week about advanced file I/O and using those file I/O exceptions while doing the cool, or using exceptions while doing the cool file I/O stuff. Okay, so there's unchecked exceptions and checked exceptions, right? If it's a checked exception, you have to do something about it, right? Like this one told us we either had to try or say that we throw it, and that's one of the differences here. So when it's nice to have checked exceptions because it forces them to put it in a try block or admit that they might just crash and they had their throws exception here. Yeah, you can just pass the buck. Say, oh, sure, I'll crash. I don't care. I'm too lazy. Or, we haven't learned it yet. I'm sorry. Sorry. Okay. So I think that's good then. We made some good progress tonight, and we can pick up the rest of this file I/O stuff next week. And then we can get to talking about the final project the week after that. Believe it or not, we are closing in on the end of the semester here. This is week 10. We have one more week of this, and then we get back into graphical programming, which is our final project, which is going to be a lot of fun. We'll have one last little bit of lecture on design patterns. Some really cool stuff. They're amazing. You take a whole class on design patterns in a bachelor's degree program. A little bit of time set aside for final work project time. And what I'd like to do is get everyone together on a Zoom call where we can all take turns sharing screens, because I can't do that on Twitch. And you can present your final projects on 4/29 is kind of the goal. Okay? So it should be a lot of fun. If you can't make it, again, it's been synchronous optional, so I understand. We'll look at how you can set up a recording for me or arrange for a different time to present it just to me. But keep that in your back pocket. Try and keep that night open if you can. When we're in person, I bring pizza. We're not in person, so I apologize. You're missing out on the experience. But usually that's a lot of fun, looking at each other's projects and showing off what we did. That was kind of the goal, okay? So I think I'll actually be able to talk about the final project next week then to give you a little extra time on it as well, since we're skipping project 4. And I'll put a new version of the syllabus out there. DoorDash you all pizzas. Sorry. You know, I don't mind ponying up a little bit of cash to get like 4 or 5 pizzas when we're in person, but 25 pizzas is a little much for the pocketbook. So, you know, you understand, right? All right, so let's see who we can go pester out in Twitch land, if there's anyone else around. Dates use the wrong format. You're talking about the international format, where in the US we do month/day/year, which is totally confusing because it doesn't go from biggest to smallest or smallest to biggest. Yes, yeah. We should have year-month-day is the best, for sure. Hey, folks, have a good night. Let's see. Let's go check out this guy who runs his little CNC shop and doing all sort of manufacturing. He's lots of fun. Let's see if I can find his. There we go. Head on over that way. It's just some interesting stuff to check out, and we'll have a good evening. If you guys have questions, please let me know. I don't know if you're having trouble unless you tell me. Okay, so let me know. Attend those study sessions Tuesday, Wednesday, Thursday, and we'll go from there. All right, take care, folks.